Welcome to this explainer. Look, if you're a print production professional, you already know that variability on the floor is the absolute enemy of scale. Today, we're delivering a high-signal, zero-fluff breakdown of the strictly required heat press metrics for direct-to-film or DTF printing. Our main goal here? To standardize your pressure, heat, and dwell time parameters. We're going to lock in these variables to completely eliminate guesswork on your production floor. Let's get right into it.
Okay, so let's dive into this. The heat press is your final point of execution, right? You can have the most finely tuned, perfectly printed, properly cured films in the world, but it literally means nothing if the final application is left to operator preference or, just guesswork. This is exactly where quality control most often falls apart in print shops. So today, we're locking in what we call the holy trinity of heat press metrics: temperature, time, and pressure.
So here's exactly how we're going to break this all down. First up, temperature and dwell time, basically the thermal transfer. Second, we'll look at the mechanical bond, which is all about pressure. Third, the mandatory post-press. And finally, we'll tie it all together by looking at why locking these metrics down matters so much for your bottom line. All right, Section 1, temperature and dwell time. Let's talk about the thermal transfer.
When that film actually hits the platen, your primary goal is to remelt the cured polyurethane adhesive, just so it can flow right into the fabric. To make that happen, your exact baseline metric must be set between 150 and 160 degrees Celsius. Or, for those of us using Fahrenheit, you're looking at 302 to 320 degrees. And listen, this isn't just a friendly suggestion. This is the strictly required operational baseline to actually activate that adhesive effectively.
But hey, heat alone just isn't gonna cut it. It has to be paired with the perfect dwell time. You need to hold that 150 to 160 degrees for exactly 12 to 15 seconds. You need to confidently communicate to your operators that this specific dwell time is just inextricably linked to the temperature. Hitting this specific 12 to 15 second window is what guarantees the perfect thermal transfer without damaging the substrate underneath.
And check out the direct cause and effect here. If you hit that 12 to 15 second window at the right temp, boom, you get the perfect melt. It's optimal flow right into the garment fibers. But if the temperature spikes too high or you just leave it on for too long, you are risking immediate damage. On cotton, you're going to scorch it. On polyester, you'll trigger dye migration. That's where the fabric's dye actually bleeds into your white underbase and completely ruins the visual integrity of the print. Nobody wants that.
Moving on to Section 2, the mechanical bond, and setting the pressure.
So while heat melts the adhesive, pressure is the actual mechanical force driving it down into the substrate. Honestly, without it, the thermal transfer is totally useless. DTF absolutely requires medium firm to firm pressure. If you're on a pneumatic press, you want to lock in 40 to 60 psi. Using a manual machine, that translates to roughly an 8 out of 10 on the manual scale. Getting this consistent level pressure across the entire platen is non-negotiable for commercial quality.
The contrast and durability here is just immediate. With locked, correct pressure, that mechanical force successfully drives the adhesive deep into the weave of the fabric. But if that pressure is too light, the adhesive just sits right on the surface. And what happens next? You're looking at premature cracking and peeling after just a couple of washes. It's a complete deal breaker.
All right, Section 3, the mandatory post-press, also known as the seal.
Okay, we really need to aggressively debunk the idea that the job is somehow finished right after the initial peel. A secondary post-press is absolutely mandatory standard operating procedure. The physical steps are super straightforward, though. Step 1, perform the initial peel of the carrier film. Step 2, cover the design with a protective parchment or a Teflon sheet. And Step 3, hit it with a secondary press for 5 to 7 seconds, keeping the machine at that exact same 150 to 160 degrees Celsius.
So why do we even do this? Well, the secondary post-press does 3 really critical things. First off, it completely removes that artificial plastic sheen left behind by the carrier film, giving the print a much more premium feel. Second, it acts as a final seal, literally driving the adhesive completely into the garment's weave. And third, because of that deep seal, it ensures absolute maximum wash durability. Seriously, skipping this step is the fastest way to guarantee wash failure.
Finally, Section 4, why locked metrics matter, and the business impact. Let's pivot from the technical metrics to the actual reality on your shop floor. Print production only scales when it becomes predictable, right? By documenting and locking in these exact metrics for heat, time, and pressure, you drastically reduce variability. It completely removes operator preference from the equation. This standardized approach simplifies execution,
It makes training your new staff significantly easier. It eliminates those costly application failures, and ultimately, it guarantees improved consistency on every single garment that leaves your shop.
So, I'll leave you with this final provocative thought to take back to your production floor today. Are your heat press metrics officially locked in and documented, or are they honestly still being left to individual operator preference? I highly recommend taking a hard look at your finishing stations. Getting this right is absolutely where your true margin is protected. Thanks so much for joining me for this explainer, and I'll catch you next time.